Well, hello and welcome to this iGCSE higher tier A-level type question in which we're supposed to derive the formula for the area of a segment and area of a sector, and also the arc length as well. Okay, now we're given this here, and it says OABC is a sector of a circle with radius r centimeters and angle theta radians, subtended at the center. Find in terms of r and theta the area of triangle OAC. Now, in the actual question itself, now this line is not there. I'll just put it in myself in this instance. Right. Now, firstly, I need to find the height CD, and CD, using Pythagoras, is r sine theta. We know that the area of a triangle is half height times base, in this case, a half CDR, and we know that CD is r sine theta. So the area of a triangle in terms of r and theta is half r squared sine theta. Okay, now moving on to the second bit, we want to find the area of sector OABC. Now we know that the area of that a circle subtends an angle of 2 pi radians at the center, and the area of a circle is pi r squared. Again, if we take ratios of the angles subtended at the center, we end up with that theta divided by 2 pi is equal to area of sector divided by area of circle. If we then cross multiply, we end up with area of sector being the area of circle times theta divided by 2 pi, which means that the area of sector is half r squared theta. Don't forget that in this instance, these two, the pi there and the pi there, will cancel out. Hence half r squared. Hence half r squared theta. Okay. Again, now we need to find the arc length. We need to find the arc length ABC. Again, using ratios again, and using circumference of a circle, we end up with that the arc length ABC divided by the circumference of the circle is same as, will give the same result as theta divided by 2 pi radians. So when we cross multiply, and the 2 pi's will cancel out, so we end up with arc length is r theta. Okay, now for this part, for this section, we have 3 marks. The next section carries 4 marks. And that says you are told that the arc length ABC is 20 centimeters and that the area of the sector is 50 centimeters squared. Show that at least one of this information is not correct. Okay? Right. The only way we can show this is that to try and find the area of this segment here. Okay, we'll try to find the area of the segment, and to do that, we know that the arc length given to us is 20 centimeters, and that's the same as r theta. We are also told that the area of the sector is 50 centimeters squared, which is a half r squared theta from there. Okay, and we can write half r squared theta as half r times r theta. Now in this case, r theta is the arc length, and the arc length is 20. So 50 centimeters squared then becomes 50 is equal to half r times 20. Okay, right. Now if you divide 2 by 2, you get 1. Divide 20 by 2, you get 10. So 50 is 10r, which that means that r is 5. If you divide 50 by 10, you get 5. So okay, so r is 5. Moving on. Now the arc length is 20 centimeters. we know that r is 5, which that means that theta has got a value of 4 radians, because if you divide 20 by 5, you get 4. Okay. Now, we want to find the area of this segment here, this one here. So to do that, if we do the area of sector minus the area of the triangle, that will give us the area of the segment. And the area of the segment is half r squared theta minus half r squared sine theta. If we factorize, we end up with a half r squared into theta minus sine theta, which is same as saying half times 25 into 4 minus sine 4. Okay, and that gives us a value of 59.46 centimeters squared. Now, there's no way that this area here is going to be greater than the area of the sector itself. So either one or both of the information given to us is wrong. Okay, so I hope all, I hope all that made some sense, and I do hope you subscribe or donate, and please watch some of my other videos. Thank you for watching, and bye bye now. Bye bye.